This video is about quadratic graphs and their properties. Here are examples of some quadratic functions, and you can see that they can be written in two different ways. You can use function notation, such as f of x equals x squared, and the third one, g of x equals x minus 1 times x plus 2, or you can write them as a two-variable equation, y equals 3x squared minus 10x plus 1, or y equals 4x squared minus 9. Again, these are some examples of the quadratic functions that we will be studying. They're quadratic because the functions are all of degree 2, and they are functions because for every input x, there is exactly one output. The goals of this lesson are to define the terms that you see here, and you don't have to write these down now because we'll get to them in just a moment, and to explore graphing quadratic functions of the form y equals ax squared plus c, a constant, and learn what the values of a and c have to do with the appearance of the graph. Standard form. So the standard form of a quadratic function is y equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. You can see that if a did equal 0, the x squared term wouldn't be there, and this would no longer be quadratic. The quadratic function y equals x squared is in standard form, and if you compare to the standard form listed above, a equals 1, coefficient of x, b equals 0, and the constant term c equals 0 as well. The quadratic function y equals x plus 1 times 2x minus 3 is not in standard form, and if it were written in standard form, you would have to use the distributive property to expand, and it would be y equals 2x squared minus x minus 3, and in this case the coefficient of x squared, a, equals 2, the coefficient of x, b, equals negative 1, and the constant term c equals negative 3. Now this is a graph of the simplest quadratic function, y equals x squared, and it's sometimes called the quadratic parent function because all quadratic functions have this basic shape, and they are all variations of this. So some might be a little narrower or wider, they might move around, but they still have the same basic shape. Here's a parabola, and I'm going to give you some vocabulary to help you describe the parts of a parabola. First of all, the line that divides the parabola into two identical parts, mirror reflections of each other, is called the axis of symmetry. For the parabolas that we will be studying, it is a vertical line. It's not part of the graph itself, but it is a line of symmetry where if you were to fold the parabola along that line, the two halves would exactly match. The lowest point of the parabola, in this case, is called the vertex, and that represents the lowest value of y. The parabola is said to open up in this position because its opening is on top. And as I said, the vertex represents the minimum value of y on this parabola. Parabolas can also look like this. And again, they have an axis of symmetry. The vertex, just as before, is along the axis of symmetry and is at the highest point on the parabola. We say that this parabola opens down, and the vertex point represents the maximum value of y on this parabola. Now here's how to graph the quadratic parent function, graphing y equals x squared. As with any type of graph, especially ones that you're not familiar with, you make a table. And in this case, we'll make a table that has x, and I'll add a third column in the middle to show x squared just for clarity's sake. So if x is negative 3, x squared is negative 3 squared, and that equals 9. Negative 2 for x, y coordinate that corresponds is 4, and so on. And then we can make a coordinate plane and plot the points as they are in the table. We'll start with negative 3, 9, negative 2, 4, negative 1, 1, and so on. And then we'll simply draw the parabola in along those points. The axis of symmetry is right up and down along the center, along the line x equals 0. The vertex of the parabola is at the point 0, 0. And notice that if you go up from the vertex to any point on the axis of symmetry and go to the right and to the left to see the corresponding points, they will be equal distances from the axis of symmetry. You can use this fact when you're creating tables and making a graph to simplify some of the process. Now I'd like you to use Desmos to explore what changes in the coefficient of x squared do to the graph. What I'd like you to do is open up Desmos and graph the line, the parabola, y equals x squared. And for all of these exercises, make sure that you leave that one on the graph so that you compare it to the other graphs that you are making. Now in the first series, I'd like you to graph each one of these functions, compare them to y equals x squared, draw them in your journal, and then what do you notice? You should stop the video for a moment and restart it after you've done that. Next, I'd like you to take a look at what happens if the coefficients of x squared are between 0 and 1. Okay, so try graphing these three, and again, after you've graphed them, draw them into your journal and write down some observations that you have about the effect of those values of a on the parent function. Stop the video. Okay, next I'd like you to clear those functions off of the graph and take a look at what happens when the coefficient of x squared is negative. First, graph these four functions, compare them to y equals x squared, and compare them to the functions where the value of a was positive. Copy those into your journal and write down some observations. And finally, do the same thing for coefficients of x squared that are between negative 1 and 0. Again, graph them, copy them into your journal, and write down what you notice. Next, I'd like you to explore what changes in the value of c do in the function y equals ax squared plus c. So I'd like you to start by graphing y equals x squared. And then on the same graph, graph each of these, draw them in your journal, and write down what you notice. And then graph each of these, draw them in your journal, and write down what you notice. And this ends our lesson. Thank you very much.